Okay, interactive atomic name swaps for Handshake. This is a protocol where two parties can trustlessly, without any type of custodian or third party platform, trade money, HNS, for a Handshake name trustlessly. It's interactive, which means the two parties do need to communicate a little bit beforehand. There's a little bit of setup involved. It's a swap in that one party has money, the other has a name, and they swap. And it's atomic in that that entire operation either succeeds or fails, meaning there is no state in which one party ends up with both the money and the name. Either the operation succeeds and both parties keep what they started with, or the operation succeeds and the swap is completed. I'll describe the protocol on a really high level quickly, and then do a demonstration with Bob Wallet, and then maybe show a little bit about the code. This protocol is based on lots of work by Mark Tynes, who implemented Sikash single reverse and has a non-interactive name swap protocol, and it was implemented in Bob Wallet by Matt Slipper for Kyokan. So on a high level, how it works is like this. We'll say Alice has a name and agrees to sell it to Bob for a certain price. They can communicate any way they can. Twitter, Reddit, Telegram, IRC, however, they need to agree on a name and a price. Bob sends Alice an address for her to transfer the name to. The first real blockchain operation is that Alice transfers the name to that address. Now, remember, in Handshake, name transfer is actually a two-step process that takes a minimum of 2 days. The designers of the protocol wanted name transfers to be very hard so that it doesn't happen by accident. So it's hard to steal a name, so that when you own a name, you really, really own it. So when Alice puts this transfer on the blockchain, she still controls the name. It's still completely under her control, and she can cancel the transfer process at any time. What the transfer does is it just commits to Bob's address. After 2 days, Alice can broadcast the finalize, which is the transaction on chain that really puts the name into somebody else's control, and that's where we do some magic stuff. So step 4 here, when the finalize would be valid, what happens is Alice creates a partial transaction that has a one output that gives her money and gives the name to Bob. That transaction is not valid on chain until Bob funds it and signs it. So Alice sends this partial transaction to Bob. Bob completes it, at which point the transaction is valid on chain. And Bob can broadcast it or send it back to Alice, and she can verify it and broadcast it. But basically, Bob will broadcast it, and that one transaction swaps the name and the money in one operation. There's a few other failure states. Alice can cancel the transfer at any time. Bob needs to watch the blockchain, and if he sees Alice cancel, then he knows the deal's off. They don't need to communicate anymore. It's just, oh well, Alice wasted some minor fees. That's too bad. The same is true as if Bob never broadcasts the finalize. He may get the partial transaction, decide never to sign it. He changes his mind. He loses his private key for whatever reason. So in that case, Alice needs to watch the chain. And if she sees that Bob never finishes his part of the deal, then she can do the cancel. And in the worst case scenario, the only thing that happens is that Alice wastes a couple of minor fees. So there's no spec for this yet. Just what you see here, it's implemented as a pull request to add a test to HSD. I'm going to open a Handshake improvement proposal at some point in the future. So I can demonstrate how this works. Now I have 2 Bob wallets in reg test mode here. So they're both running on my computer, and they're connected to each other locally in a testing environment. And on the left, we'll say this is Alice over here, and this is Bob up here. And I've already, Alice has already acquired the name Atomic by bidding and winning an auction, and she's already registered the name. You have to register a name before you can do a transfer. So let's walk through it. Alice goes to manage my domain. She might have DNS records here. Down at the bottom is the transfer area. And you can see that she can initiate a transfer by putting the recipient address. It's pretty easy. So let's say that Bob wants to buy the name Atomic. So he gets his receive address and sends it to Alice in any way possible. Text message, Reddit, Twitter, whatever. Okay, so Alice broadcasts a transaction. And like I said, now the name is in a transfer state committed to Bob's receive address, but Alice still controls the name. She can cancel at any time. I'm going to fast forward the chain here by generating 20 blocks, let's say, move things along. This is the part of the process where on mainnet you would have to wait 2 days. We're going to zip through it here. You can already see Bob has detected the advance in the blockchain, and this is where Alice would cancel if she decides that the deal is off. If she finalizes the transfer, Bob gets the name automatically without paying for it. So this would, if Alice is transferring the name to another wallet or to a different custodian, or if they had some other payment mechanism, she would click finalize, the deal will be done. Finalize with payment is where it really gets interesting, and that's where we're going to demonstrate the atomic swap. So Alice clicks finalize with payment, and this is Bob's address down here, and we can see, yes, it ends with 4TF, and that's the address here. This address is pulled from the transfer covenant. It's already committed to on the blockchain. Alice enters the price. This is something else that Bob and Alice would need to have confirmed out of band. Let's say she wants to sell it for 1.123456 HNS. And so now at this point, Alice enters her password because she is actually signing something. And what you see now is a partial transaction. This is not a valid transaction. She will send this to Bob in the next step, but we're going to examine this a little bit. This has her signature. That's why she had to enter her wallet password. And hopefully I can demonstrate decode raw transaction with that blob that I just copied from Alice's wallet. Okay, so this is what the transaction looks like right now. And this might be too technical for some people, but it's interesting to see. The transaction has one input. This is the name itself. This is the name as Alice won it. It's the output of maybe a register covenant or something like that. It represents the actual name. The first output is the finalize, and this goes to Bob's address. And this is how finalizes work. The input 0 and output 0, they need to match, and this is the name coming in and the name going out. The second output on this transaction is 1.123456 HNS going to Alice's wallet. This address was just pulled from her wallet. And so you can see this is invalid because it creates money. There's no money to pay that 1.123456 HNS. So actually, if I try to send raw transaction, the CLI command actually returns, but I will show you the log here, and we can see that the verification of the transaction failed. So this transaction, as it is now, being partially signed, being incomplete, the error here is insufficient priority. Doesn't really matter what that means. This transaction cannot be broadcasted. It is not valid. So we need some more steps. So Alice is going to transmit this blob to Bob somehow. Email, whatever. It doesn't really need to be private. It's eventually going to be on the blockchain anyway. So they can transmit it however they like. So we're going to copy this and send it over to Bob. Now in Bob's wallet, he is going to go into his domain manager and click this button, claim name for payment. And here's a big area to paste the blob. And when Bob clicks verify, he'll see his own address. Remember, it ends with 4TF. So that is the address the name is going to. The name is Atomic. The address receiving the funds, this is Alice's wallet address that the money is going to go to. And the price is 1.123456 HNS. If Bob agrees to these terms, they should be the terms that Bob and Alice agreed on out of band in the beginning. He will click pay and transfer. Bob enters his password. And now the transaction has been signed by Bob and broadcast to the network. And as soon as this transaction is confirmed, the names are atomically swapped. So we will generate, let's say, let's just start with one block and make sure that this works here. And if we go to Bob's portfolio, we see he has received a finalized domain transaction. Alice has received the funds, 1.123456 HNS. That's good. Alice's domain manager is empty. Bob's domain manager has the name Atomic. Hey, it worked. We just did an atomic swap. There's an issue with Bob displaying swap names right now, but that should get resolved soon. So we can look at this transaction, hopefully. HSD CLI TX. Okay, so this is the final version of the transaction, the one that actually went onto the blockchain. And you'll notice it's a little different than the one I showed you earlier. That was only partial. The inputs here is the transfer covenant, and now it has a new input. It has this second input that was added by Bob's wallet, and it added a coin. In this case, the coin was 2,000 HNS because Bob mined a block. So Bob is added an input to this transaction, funding it with 2,000 HNS. The outputs, here's the finalize. That's where the name goes to Bob's wallet. That's nothing new. This middle, the second output here is Bob's change. It's a little bit less than 2,000 HNS. This goes to Bob's wallet as his change. And then finally, here's the 1.123456 HNS that Bob paid Alice. This is Alice's output. So you can see, because this is one transaction, the whole operation either succeeds or fails. Either they swap the name and the money, or they don't. If this transaction does not get broadcasted, the state of the name and the state of the money does not change. Pretty cool. So this is a way that Alice and Bob can, or any Handshake user with Bob Wallet or anyone else who implements this protocol, can sell their Handshake TLD on a secondary market without any type of custodian, third-party platform, no escrow or anything like that. We can briefly take a look at the code. It's kind of interesting. I'll just show you sort of the magic tricks. When the first stage of the process is that Alice initiates a transfer, just like any other transfer that goes on chain. And then the finalize is really the magic part. The finalized transaction is the one where we do something really funky. First, it starts off where Alice creates a transaction that I've sort of like drawn here, where Alice takes the name into input 0, and creates a finalized covenant which goes to Bob's wallet, and then adds an output to her own wallet. And like I showed you, this transaction is not valid because it creates money. It requires funding. This is what Alice sends to Bob, is this, so that there's a transfer to finalize and a payment to Alice. When Bob gets that blob, he decodes it and makes sure that a couple things are correct, that it's his actual wallet address, that it's actually the name that he wanted, that it's the price that he wanted. And then what Bob does is he adds money to the wallet. So he adds this input number 1, his funds, which is an unspent coin from his wallet. And then the wallet will automatically make this change address. And then we have to sort of rearrange these things, and I'll explain why in a moment. And the final transaction looks like this here. So input 0 is the name as it exists right now. Output 0 is the finalized to Bob. Input 1 is Bob's money. Output 1 is Bob's change. Output 2 is the payment to Alice. The reason it needs to be switched around like this is because of a magic trick in Handshake called sig hash single reverse. And this is it's a sig hash flag that is unique to Handshake. Bitcoin and all other UTXO coins have different sig hash flags where when you sign a transaction, you decide exactly what part of the transaction you are going to sign, to commit to. Usually you sig hash all. You just sign all the inputs and all the outputs. That's the easiest thing. It makes the most sense for most applications. In this case, because we have two parties collaborating on a single transaction, Alice is going to sign the transaction before it's done. So she needs to sign it in a way that tells the consensus mechanism, hey, I know this transaction is going to be mutated. I'm only going to commit to a few parts of this transaction. Someone else is going to finish it. That's okay with me. So in Bitcoin, you would do something like, it's called sig hash single, where you would sign the input and the corresponding output, and that's it. We have that in Handshake as well, but the interesting thing about this, particularly in Handshake, is that the transfer and the finalize already need to be input-output linked. They're already going to be at the same place. So what we need to do is commit to the input being the name and the output being somewhere else in the transaction to confirm Alice's money. Because what Alice wants to do is create a signature that says this name is going in and the money is going out. That's what Alice wants. She wants to send the name and receive the money. And so that's what she's going to sign. And because those are not on the exact same input-output index, she signs one input and a different output. And that in Handshake is called sig hash single reverse. It was implemented by Mark Tyneway last year before mainnet launched. And so what Alice actually commits to is this input transfer coming in and the payment. And you can see it's called single reverse because the top and the bottom are what's being signed. When Bob adds his money and completes the transaction like I'm shown here, he uses sig hash all. It's not that exciting. Bob just basically completes the transaction. Okay, so that's it. Now we have a decentralized secondary marketplace. We can test it out by linking two Bob nodes together, and I've demonstrated how Alice and Bob can transfer a name for money. Oh, and we can also see, that Alice got the money over here, Bob got the name, and that's it. Handshake to the moon.